Welcome everyone. Please pull out the worksheet called In-Class Problems and find problem number 12 on the back. If you don't have it out, hit pause, and when you find it, unpause it. So in-class problem number 12 on the back, let's take a look at it. It says a baseball is hit straight up for a pop fly. It takes 2.2 seconds until the catcher catches it. How high did the ball make it? Okay, now I crossed off the other problem, the other part for right now, just because I screwed up and this is my second take on it. But that's something we're just going to pretend like it's not asking right now. Right now, we're only focusing on the first question. So, based upon the information that's given and based upon identifying the problem types, hit pause, make a list of your variables, then based upon these and numbers within the problem, when you're done, unpause it. All right, now that you've gone through and you've read through the problem types and you determine information from the problem, you see this 2.2 seconds straight up. How high did it go? That's my question mark. So we go over to our list and we go through and we look at these problems and we say, is it a 1D motion problem? Is it only moving the X or the Y? The answer is yes. And it's only moving the Y direction, so we are going to make a delta Y column. Okay, there's my delta Y column. You can then go over here and say, is it moving at a constant velocity? No, it doesn't mention anything about constant velocity or acceleration equal to 0. Okay, hot fly, how high does it go? Is it a free fall? Is gravity the only force acting on it? The answer is yes. Gravity is the only force acting on it. Therefore, this is negative g, which is equal to negative 9.8 meters per second squared. Does it say anything about the object being dropped or falls? Nope. It says the ball was hit straight up. No. Is this a max height problem? So we got to look at this. So we have the ball. The ball is hit straight up in the air. It reaches maximum height. And then it comes back down, right? But what this question is asking is, how high did the ball make it? We only care about the way up. So we care about the ball at its maximum height. That's the question being asked. Okay, we're trying to figure out that. So is this a max height problem? Yes, this is a max height problem. So therefore, we know the velocity at max height is equal to 0. Now what we have to do is we have to decide, is that initial velocity or is that final velocity? And in this case, if we're going to go from where it's hit to maximum height, that's going to be my final velocity. This is not a delta y is equal to 0 problem, because we're looking for the max height. Now we got to be careful though, because this number right here, this is from here, the ball to here to max height to come back down. This is the total time. This is the total time in the air. Now, this is a column specifically for maximum height. So this time needs to be maximum height time. The time here, if we looked here and I kind of scribbled it out, it's the time for delta y is equal to 0. The total time in the air is twice that of the max height. So because this is the total time, we can take our total time of 2.2, and if we divide it in half, this is 1.1 seconds. This is T2 max height. This is my time for my max height column. Because it goes up and comes back down, this part is a delta y problem. Okay, so now what we want to do is we want to go through and we want to pick an equation that doesn't have an initial velocity but does have a delta y. So we look at our things and we look at these and we say, which one is it? And hopefully you're saying, I don't see one, right? There isn't that choice. That's the one variable that we always have to have. So you say, well, what the heck am I supposed to do? What we're supposed to do is we're going to have to go through and we're going to have to solve for this one first, then plug it in to find something else. Okay, so which equation do we want to choose? It really doesn't matter, but equation number 2 is a pretty simple one. It's a pretty nice one. So if we say equation number 2, VF is equal to VI plus A times T, my final velocity was 0. So we can say 0 is equal to VI plus negative 9.8 times our T of 1.1. 0 is equal to VI minus 10.78. Now, in order for me to get VI by itself, I have to add 10.78 to both sides. So my VI is equal to a positive, I'll just put the positive to reinforce that, is going to go up initially right here at 10.78 meters per second. Now, once I figure that out, 10.78 meters per second, once we know that number, now we can go through and we can pick an equation for delta y. It doesn't really matter, once again, which equation. I'm going to use equation number 5. So equation number 5 says delta y is equal to VF plus VI divided by 2 times T. My final velocity at max height is 0. So my delta y is equal to 10.78 divided by 2 times 1.1. And when we go through and we do the algebra, my delta y is equal to 5.93 meters. That is my answer for right here. Now we can go through and we can say, with what velocity was the ball hit? Oh, that's asking what is my initial velocity, which we had to solve for in order to get to that final step. So we're actually done already. If you have any questions, please let me know.